All right, if that section was important, which it was, of course, this next section is going to be just as important. Not necessarily the distributive property, which is important, but combining like terms is it's gonna simplify a lot of these problems into even more smaller manageable problems. So it's gonna work like the order of operations, but different. Okay, it's gonna make things nice. It's gonna make things convenient in the end, but we got to look at that. But before we do, now again, I'm showing you guys this problem, okay, and I want you guys to try it out. Just see if you can simplify it, okay. That there's a couple misconceptions that almost always come up with a problem like this. Just starting out without any background. Again, please do try it. You may not know how to do it, but try it anyways, and then we'll learn ways not to do it, okay? Then we'll go over ways to do it, okay? But just take, I don't know, 30 seconds and see if you can simplify this. All right. Hopefully you guys tried that out, and there's a few different answers that come up. Just to start out with a problem like this one, is you may have gotten, let's see, what is that? Maybe 14r to the power of 5, maybe 14r to the power of, I don't know, even 9, or 14r to the power of 8. Hopefully you guys know where that 14 is coming from. It's just taking all those numbers and combining them, -9 plus 17 plus 6. And then a lot of students look to combine the r's in that case, okay? But none of these three are correct, okay? So none of these are good. There's other things that we have to do before we start looking at simplifying these. And well, we'll come to that, back to that problem, okay? But let's just look at some things that we need to, some vocabulary that we should be familiar with when we see problems that say combine like terms. Now, like terms, of course, comes from terms. We need to know what terms are, generally speaking. So they're just values in a math expression that are separated by addition or subtraction. All right? So in this expression that we have from that last problem, -9r to the power 4 plus 17r to the power 4 plus 6r. Right now, this has three terms because we got this -9r to the power 4, which is separated by this addition sign with 17r to the power 4. That's our second term. And then this is separated by from 6r with this other plus sign. So remember, it's always separated with addition or subtraction. Multiplication or division don't matter. It could be a really long multiplication term, but it would still be considered one term, okay? Now, like terms, I mean, this says terms in a math expression that have the same variable or variables, which also have the same corresponding exponents. So it's not enough just to have the same letter, is what that's saying. It has to have the same exponent as well. So on this one where we see r to the power of 4, again, I'm not really looking at the number here, the -9 or the 17. I just want to look at r to the power of 4. Since we have the same letter and the same exponent, I could say that these two are like terms. But the 6r, this one does not show the exponent. So technically it has an exponent of 1, but it's not the same as 4. Not having or showing the exponent is not the same as having exponents of 4 like we see in those two. So 6r is not a like term with -9r to the power 4 or 17r to the power 4. But these two would create a set of like terms. Another thing to keep in mind with terms is that they always take the operation addition or subtraction to the left as their sign, which it talks about here in the coefficients. The coefficient is the number that's being multiplied to the letter. So up here where it says -9r to the power 4, -9 would be considered the coefficient. Or right here, this term 17r to the power 4, 17 is considered the coefficient. And it would be considered positive 17 because the sign or operation is addition. And then 6r, the coefficient of r there is 6, positive 6. Okay? So it's the base numbers of a term, or you could say it's the number being multiplied by the letter. And that would work as well. So where it said to simplify in that last, so when it says simplify an expression like this, it's really saying combine like terms if you can. And right here I can see that negative 9r to the power 4 and 17r to the power 4 are like terms because they both have r to the power 4. Then I would combine the exponents. So that'd be negative 9 plus 17, which should come out to 8. So that would be 8r to the power 4. And then the 6r, it has no other like terms to combine with. So it just stays as positive 6r. So that's an r right there. Sorry about that. So the final expression simplified is 8r to the power 4 plus 6r. Now again, if that still isn't making a lot of sense, don't worry, but we're going to see we're going to get a lot of experience with these. But the sooner you can acquire this skill of combining like terms, the sooner when we get to solving equations, the sooner that will become easier for you. So in a problem, these two problems, this is two different questions right here. It's just saying what is the coefficient of x, like this one. Here now, at this point, since this is still very new, a lot of students would say there is no coefficient of x. Well, the truth is that there is a coefficient of x. You just can't see it. And this is a kind of one of those special values of math people. It makes them feel really good inside. It's 1. I didn't really put that in a good place, but remember how I told you guys in that first module that math people are pretty lazy? Well, if you had to write negative 1x and you had to write it a lot of times, it makes people, well, math people pretty grumpy. So they just said, you know what, we're going to make that a phantom 1 and not show it. It's there. It exists. It can see us, but we can't see it, which, you know, it is kind of creepy. But it's there. It's a phantom 1. It exists, okay? So if you see terms like this, if you wanted to show that 1 right there because it's kind of creepy, then show it, okay, if you'd rather see it there. So the coefficient on this first term is negative 1. Bam. We're going to see a lot of phantom 1s. Not only in this class, but in any other math class you take. You'll probably see a lot of phantom 1s, excuse me, but, and that again is really just because math people were lazy and they're like, we don't want to show 1. It's the identity property for multiplication, so we don't necessarily have to show it. Again, they made the assumption that everyone just knows that it's there, but not everyone does. So if you like to see that 1 there, please do show it, okay? So on this next problem, right, I guess before I found the coefficient of x, I should ask how many terms there are, and you should know that there's 2 terms in this next part, right? The first term here is 8. Now this next term would be considered negative x. And again, it's just not showing that phantom 1, but it is right there. And again, maybe this would help to see that if it was shown as 8 plus negative 1x. Because now we can see the coefficient for sure here is also negative 1. Now this next problem is where we really see how phantom 1s, or making them phantom 1s, is, well, it's kind of efficient, right? Because if I said on this last term I got x, just x, right? What is the coefficient of x? Well, a lot of students at this point would still say 0 because I can't see it. But the truth is it's there. You just need to show it. It's a 1. It's 1x. Now this one, it's positive because if it were negative, it would have to show it like it did for this one. But since it doesn't show a negative sign, it has to be just a regular positive. That's positive 1. It's 1. That is the coefficient of that x. Now again, you may be thinking, well, this seems kind of frivolous, but it's very important that you understand phantom ones because they do exist, they're there, and sometimes it may be beneficial to show them like we've shown in these three cases. All right, let's go through this problem. We're going to identify the terms, all the terms, then the like terms, and then the coefficients. All right, now there's a big problem, right? We don't want you to feel overwhelmed by problems just because they're big. We should be able to do these no matter how big they are. So I always just start with the term that is farthest to the left. Well, I apologize. Let's go through the terms. And yes, I still start on the left. Well, the terms, there's a big list. I've got the 4x. Now remember, they're all separated by addition or subtraction. So that's just a simple positive 4x. Bam. There's my first term. My next term, there it is, positive 6. Now again, I don't need to show that it's positive 6. Otherwise, it just starts looking like the original expression. Next up, I got plus 2x to the power of 2, so that's my next term. That's a positive 2x to the power of 2. All of these are positive because we're just using addition, right? And the 4x was positive because it's not showing the sign. But this next one, remember that terms carry the operation to its left as its sign. So this one would be, it's not 9, it's negative 9. Next up, we got, this would be, it's not just 5x to the power of 2, but since it's minus 5x to the power of 2, it's considered a negative 5x to the power of 2. All right, now, those last two, again, that's key that you guys understand that by subtracting, it makes the sign of a term negative, okay? So this next one, its sign, again, since it's minus, is negative. And that'd be negative 12x there. The next one there is at positive 4. Then we got a negative 5x. Then that's plus 3x to the power of 2, so that's positive 3x to the power of 2. Then we got another positive 4. And then a positive 3x. Now again, there's a minus 6, so that would be considered a negative 6. Almost had enough space there. Next is plus 2x, so that's my next term. And the final term there, again, if you didn't like to show it as x to the power of 2, you could show it as 1x to the power of 2. And again, it's positive because it's plus. So we're going to list all of the like terms. Now again, I'm going to start with my term farthest to the left. Okay, I've got that 4x. Okay, so I'm just looking for any other terms with just an x. I don't want to see any exponents with the x, because this one is not showing the exponent for this 4x, okay? So I'm just looking through this list. I got 6, 2x to the power of 2. That's no good because it's got the exponent. Negative 9, negative 5x to the power of 2. No good. But I do have this negative 12x. So that is my other like term, negative 12x. Okay, just keep going through the list. We got 4, then negative 5x. That's my next like term because it has an x with no exponent. Next, 3x to the power of 2. Again, no good. 4, no good. But 3x, we got that one. Again, just with the x. And then the last one in this list is that positive 2x. So this is my list of like terms with x's. But the next term in the problem was that positive 6 right there. Now this one, we call this a constant, okay, because it's just a number. It doesn't have any variables with it. You could even call it a coefficient. It doesn't show the variable with it, okay? So 6 is a constant. I need other constants or terms without any variables, such as negative 9. Then we got this 4. And this 4, and this negative 6. So these are all like terms, which I'm going to put in a different list. And yeah, I'm using purple here to show that it's a different list of like terms. So we got 6, we got negative 9, positive 4, and also negative 6. So that is like terms, all of which are constants. So they have no variables. And then that next term that I got right there, 2x to the power of 2. So I'm looking for all the rest of the terms that have x to the power of 2. And I'll list it with its coefficient, okay? So we got 2x to the power of 2. And all the rest of the terms are x to the power of 2. So it's, next one is negative 5x to the power of 2. Then we got that 3x to the power of 2. And then this last one, again, you don't have to show the phantom 1, but you can if you'd like. Positive 1x to the power of 2. Now, by separating these like terms together, you could say, I'm going to simplify this thing by combining them all together, okay? Which we'll get into. But let's list the coefficients, all right? So the coefficients, the numbers being multiplied by letters. So in this case, it should be 4. The 6 should be considered a constant. And I'm forgetting on the homework if they want that listed. We'll actually check that. But we got 4. And then the x to the power of 2, I got that 2. That's also a coefficient. See, and then we got this negative 5 here. That's also a coefficient. The negative 12 is a coefficient. The negative 5 there is also a coefficient. And then 3. Again, I'm looking for all the letters and the numbers being multiplied by them, right? So the next one, we got another 3. I'm just going to put in the list. That's okay. And then we got the 2x, so 2 is the coefficient. And then 1x to the power of 2, so coefficient of 1 there. So these would be considered all the coefficients. Again, the constants would be considered this purple list of values right there. Now, this one does say to simplify. So I'm going to start with the x's, and you can start wherever you want. But see how we got all these x's in this list right there? Well, what do we got? We got 4, we got negative 12, we got negative 5, we got a positive 3, and a positive 2. Just combine these, and that will tell you your coefficient for the x simplified. Okay, so 4 minus 12, that'd be negative 8, minus 5 is negative 13, plus 3 is negative 10, plus 2 is negative 8. So after combining all the x's, I simply get negative 8x. Okay, and that simplified all of the x's for me. Next up, we're going to combine all of the like terms that are constants, so just the numbers. So I got 6. Again, this would read as 6 minus 9 plus 4 minus 6. So 6 minus 9 is negative 3, plus 4 is 1, plus 4 is 5, minus 6 is negative 1. And that simplifies all of the constants. Next up, we'll simplify all of the x squared, so this should come out as something x squared. And then I'm just adding all the coefficients. So 2, you could say minus 5, that's fine, plus 3, plus the 1. So 2 minus 5 is negative 3, plus 3 is 0, plus 1 is 1. And that's a positive 1. So the final expression here, simplified, would be negative 8x minus 1 plus 1x to the power of 2. And again, if you said, I'm going to show that as a phantom 1, so be it, okay? Now, it also does not have to be in this order. If you had shown it as, let's say, I don't know, x squared, x to the power of 2, minus 8x minus 1, that would also work. And even on the homework, it should not matter what order you put them in. Sorry, these two are like terms because they have the same letter, x, and the same exponent for the x, which is not shown. So in this case, all we're really doing is we're taking negative 3 plus 9, and that is our new coefficient of the simplified expression with x. Negative 3 plus 9 is positive 6. That is fully simplified right there. Well, what about a problem like this one? 4 terms, okay? 4 terms. You know, you guys take 15 seconds, see if you can simplify this one, all right? 15 seconds, go. And hopefully that was enough time for you guys. If not, again, just finish up and then compare your answer with what we get. So again, I'm just looking to combine like terms. So I'm starting with, I always just, again, start with the term farthest to the left, negative 6t. So I'm looking for any other terms that have a t in it with not showing the exponent, which right here is that 14t. Well, for t's, that would be like taking negative 6 of them and then adding 14 of them. So really, we're just taking negative 6 and adding 14 to it, which gives us positive 8. Yeah, positive 8. All right, so that takes care of the t's. Next up, all I have left is constants, like this positive 5 and this negative 13, which we will combine. So again, that's just really 5 minus 13, or 5 plus negative 13, which comes out to be negative 8. And again, this reads, the final expression simplified reads 8t minus 8. And that would be considered fully simplified. All right, we did briefly cover the distributive property before, okay? One thing we want you to remember is that the distributive property is multiplication. Because between the a and that parentheses is multiplication. Well, we need to go back and think about what multiplication actually is. Multiplication tells us how many sets of a certain value that we have, right? So it's not that we have a sets of b, but it's a sets of b and c, which is why it shows as a times b here, because you'd have this many groups of this, but you'd also have the same number of groups of the second value as well, and then just keep the sign right there, okay? Now if it were set up like this, let's say that we saw something like this, and again, this is very abstract, so these these letters would be shown as values in the problems for the most part. Like, we'll see some x's. Maybe I'm getting ahead of myself. But we could see it like this one, okay? So it works with addition or subtraction. Again, you're just distributing this value on the outside of the parentheses to all of the terms on the inside of the parentheses. So in this case, we're showing distribution into 2 terms, but it is possible to distribute into 3 different terms. So if we saw something like this, it could end up being distributed into 3 different terms, like this. All right, and then we'll show a triple rainbow. Those double rainbows, man, they can get you. Videos have gone viral about those. So in module 1, right, it would show something like this example, 3, and then you'd have maybe 2 plus 5. Okay, and if I remember, I'd even said use the distributive property then, but it's not required. Like this one, there's no letters. You could say, I'm just going to do straight order of operations. I'm not going to distribute. You could still distribute to find the answer, but it's not required that you do. The one we definitely need to distribute, and it won't tell us usually outright, do the distributive property. It just stays simplifying, is you'll see an x like this. Well, at this point, now the question for the order of operations would be, well, how do I combine x and 5? Well, going back to what we saw in one of the previous slides, right, is these are not like terms. The x and the positive 5 are not like terms, so you can't actually combine them. Well, I guess maybe I didn't address that well enough, but if terms are not like terms, you cannot combine them. They have to be like terms before you combine them. So in this case, this is where I would say, well, you're going to distribute the 3 into the parentheses. You'd have 3 times x plus 3 times 5. And again, I mean, that could be simplified, 3x plus 15. But that's when you know you need to distribute, is when you can't simplify on the inside of that parentheses, because the order of operations, I mean, we can still use it, but we can't combine like terms. I'm sorry, unlike terms. So we get confused, and a lot of times on tests or quizzes, they'll throw problems like this at you and be like, hey, distribute now. Well, with distribution on this one, remember that terms are separated by addition and subtraction, and you're only distributing to each term. So in this case, you're really only distributing the 6 into this one term. It's not distributing it into the 8 and the x, because in between the 8 and x is multiplication. So it's like saying I've got 6 groups of 8x. Now, not that you'd have to, but like if you were to rewrite this as an addition problem, it'd be like 8x added to itself 6 times, right? Right, 6 8x's added together. Well, these are all like terms with x's, and then you do 8 plus 8 plus 8 plus 8 plus 8 plus 8, which is 48. Well, you could have just done 6 times 8, which is 48, and then just kept the x. Okay, so be careful when you see problems like this. There's just a small tendency for some students to say, I always have to distribute to 2 terms. It's not necessarily true. Sometimes you only distribute to 1 term. Sometimes you distribute to 3 or 5. You just never know. But remember that terms are separated by addition or subtraction. Well, what if I'm distributing a letter? Well, the same concept applies. It's like m groups of 5m. I don't know how to show that because I've only got, or I don't know what m represents. But I know that it would be, well, let's rewrite that. M times 5m, right? In fact, I'll make it 5 times m. If I use the commutative property of multiplication, I could rearrange this as 5 times m times m. Well, now I've got repeated multiplication with the m's. So I could just say it's 5m to the power of 2, and that now would be considered simplified. All right, so on this one is not meant to confuse you guys, but what we want you to understand is that, I mean, really this one just is emphasizing that you cannot combine unlike terms, right? But you can multiply unlike terms like 10 and x, or 10 and 1x, really. So 10 times 1, that's 10, and then keep the letter x. And then we'll distribute to this next term, 10 times 2, right? 10 times 2 is 20. Then keep the letter and keep the operation subtraction in between. So simplified, this becomes 10x minus 20y. It stops here because I have a term, the 10x in green, and then my other term there, the negative 20y, they have different letters. I mean, they're letters, but they're not the same letters, so I cannot combine those from there. Yeah, let's address that. Let's say that this 2y, let's say it was 2x, right? Well, you could have said, I'm going to simplify 1x with this negative 2x to start with. I mean, not everyone would notice that in the beginning, and you could say, well, I'm going to distribute, and you could still simplify it and get the same answer anyways. Problem like this one, again, it has 3 terms on the inside of that parentheses. There's no like terms to combine, so really we're looking to just distribute the negative 4 into each term. Now right here I've got negative 4 groups of 2x. So negative 4 times 2 is negative 8. So that'd be negative 8x's. So that takes care of that. Right now, I'm just going to keep that operation, the minus right there. And we'll distribute the negative 4 into the 8. Now, if you were like, I'm going to distribute that negative 4 into negative 8, you're still correct. And I'm going to show you why here in a second. But if I just did negative 4 times 8, you're still good. That's going to become negative 32, right? I'm going to address that here in a second, but let's do this last term. I got negative 4 groups of 3z. Now, negative 4 times 3 would be negative 12z. And that operation was plus between those. Now, this is pretty good. Like, this is mostly simplified. But if you were to type this in as an answer on either the quiz or the homework, it's going to mark it incorrect. What they want you to do is fully simplify with the minus negatives and plus negative stuff. So remember, minus negative really makes that a plus sign right there. And then adding negatives is the same thing as subtraction. So this comes out as negative 8x plus 32 and then minus 12z. See, this still shows that 12z, it's negative because remember, terms take the operation immediately to its left. But we did have to change the sign completely of that 32 because it was minus a negative, making it really a positive 32 right there. But again, this may feel weird right now because it's like, well, I don't like seeing answers with lots of stuff in it. But the truth is, this is fully simplified. Like, I can't simplify it. I could rearrange it, but that wouldn't mean necessarily that it's simplified. So some students, when we get to a problem like this with simplification, it's like, well, what number am I distributing? And the worst thing you could do, so this is what you should not do, is distribute the 2 into the parentheses. And the reason we don't want to distribute the 2 in parentheses is because it's not being multiplied by this set of, the 2 is not being multiplied by the set of parentheses. There's subtraction between it, so that's no good. Okay, please do not distribute that way. What we do want to see is a value to distribute. And this is where that phantom 1 becomes pretty handy. In fact, you're not even distributing just 1 into this because remember, this term right here is considered a negative 1, right? You could say it's plus negative 1 right there. So I'm really distributing a negative 1 into the parentheses. So when I show the work for this, right, my first rainbow there is negative 1, and that's a 1x times 1x. Negative 1 times 1 is negative 1, so that's negative 1x. And then we'll distribute the negative 1 to the 5. So negative 1 times 5, which is negative 5. So right now I got negative 1x plus negative 5, and I'm sure you can show that in parentheses. Don't forget the 2 out in the front. And you can show that as plus as well if you'd like. But at this point, you could say, well, I've got 2 like terms, right? I've got the 2 and the negative 5. They're just constants. So I could combine those if I'd like to. In fact, I'll use a different color there. So 2 and negative 5, right? 2 plus negative 5, that's going to give us negative 3. And there were no like terms with the negative 1x to combine it with. So I'm just going to keep it as negative 1x. And this, again, is fully simplified as far as I can take it. Now let's say that you're like, well, my order was different. I wrote negative 3 minus 1x. All right, look, that's the same exact answer as I came up with. The order's just different, right? I still have the 2 same terms, and that's what's important. You have a negative 1x and a negative 3. So that shows the negative 3, and the minus 1x makes that term a negative 1x. As long as your terms match, it would still be fine. So, sorry, I'll put or in between those. Let's say that you wrote negative 1x plus negative 3, right? So I'm assuming that's your question. Yeah, so if you were to write it like this, the homework would probably mark that incorrect because, and again, this is just, it's a minor technicality that sometimes costs points, but a lot of math people would say, look, that's, you got plus and negative there. That's not necessarily, it's not fully simplified, technically speaking. To fully simplify that, we need to show as little amount of writing essentially as possible, which would be negative 1x minus 3. And I guess that really is the only difference back, right? It would be combining like terms. If I went back to this part of the problem, it's 2 plus that negative 5. Well, what is 2 plus negative 5? It's negative 3. Well, you could show this as plus negative 3 like we've shown right here. But again, it's just more simplified to show it as minus 3. Again, it's more about the value of the term. Plus negative 3 shows the term as negative 3, but showing it as minus 3 still shows the term's value as negative 3, but I've written less. All right, well, here's a problem. It's kind of a big one. Now remember, just break this down into smaller parts, and this hopefully won't feel so overwhelming. So if I looked at what I'm distributing first, and we should distribute first when we look to simplify problems, is I have to distribute the 10 into this set of parentheses, and it's only to that set of parentheses because it's only being multiplied by that set of parentheses. And then this I would show as negative 2. This negative 2 here is being distributed into this set of parentheses. So, and yes, that is a negative 2, because remember that the sign of a value takes the operation to its left as its sign, so that's considered a negative 2. But again, I only want to focus on one at a time, so I'm going to look at the 10 distributed. So I would start with 10 distributed into 3x. So that's 10 groups of 3x, which would give us 30 x's. And then also 10 groups of 7, which is 70. Now, we could say it's positive 70, which would show us plus 70, which would simplify that, those two terms right there. Now, next up, I got negative 2 times 4x, right? Well, negative 2 groups of 4x would be negative 8x. And in this expression, I'm going to keep that. Instead of writing it as plus negative 8x, I'm just going to keep it as minus 8x, because we haven't simplified the full expression yet. Just like this next part, right? Like I could say that's a positive 7 right there. So I could say I've got 2 groups of positive 7, negative 2 groups of positive 7. So negative 2 times 7 is negative 14. So instead of writing that as plus negative 14, I could just show it as negative 14. Well, then we got that plus 13x between there. So this is my full expression right now. Unsimplified, but the full expression. 30x plus 70 plus, oh, that's a 13x, sorry. Minus 8x minus 14. Well, from here, I just look for any like terms to combine, starting with, for me, the x's. So, combining the x's, right? I got 30 of them. Then I got 13 of them. Then I got negative 8 of them. So I'm just adding these together. 30 plus 13, bam, 43. 43 minus 8, 35. So by the time I combine all of my x's, I would have 35 of them total. So that takes care of all of the x terms. Next up, I need to focus on the constant terms, which are 70 and negative 14. So that's really just 70 minus 14. 70 minus 14, we'll show the word for that one. 70 minus 14, we'll borrow. 10 minus 4 is 6. 6 minus 1 is 5. And that's positive 56, so I would show it as plus 56. So my final expression, 35x, and a positive 56.